But the example that I'm going to show you, which I like a lot, is called social science, under the heading of social science. There's such good, interesting things here. You want to build a model of the spread of AIDS or SARS. If you want to see how the traffic in Hong Kong can be as bad as it possibly is, you can. There's a very interesting model of traffic. But this is one I like a lot. It's called segregation, and it concerns a city in which there are two kinds of people: red people and green people. And it turns out that people of one colour or the other are very happy to live where they live as long as 30% of the people that immediately are next to them are the same colour as they are. So, you're a red person, and you're a green person. That's okay, but now you look around you, and if there are too many green people, you start to feel uncomfortable. You don't like too many green people. But you're a green person, and you're okay as long as there's enough green people around you. And then if there's too many red people, you feel uncomfortable. So this is a very complex phenomenon. I don't need to explain to you why in different parts of the world this is a really important and quite, in some situations, absolutely deadly question to think about. How is it that people behave if they feel threatened by different kinds of people? But let's stick to red and green because it's less problematic. And I've set, you see this little slider here? I've set this slider here to 30. I've set this number to 2,000. So there are two, it doesn't look like it, does it? There are 2,000 red and green people on the screen. Is the colour clear? Can you see the colour? There's going to be some graphs here, which today I just want to ignore. And I'm going to let it go. And make it go slowly. And what's going to happen is, the computer's going to tick like this. You won't hear anything. I don't know how many per second. A few per second. And at each tick, every single blob says, am I happy? If I'm happy, I'll stay where I am. If I'm unhappy, I'll randomly jump somewhere else. That's it. So actually, when you look at this, I'm not going to show it to you, but when you look at the computer program that makes this program work, it's one line. There's lots of stuff about having boxes and the colours and all that, but that's easy. The actual program is one line. Stay still if you're happy, jump randomly if you're not happy, and let's see what happens. Go. So very quickly, it stopped now, because everybody's happy, as happy as they can be. And you see that there are some red people living in the middle of green neighbourhoods, let's call them. There's some green people living in the middle of red neighbourhoods. There's a little bit of clumping together. And I set it so that 30% was the happiness line. Let's change the happiness line to, I'm not sure if we would like me calling it the happiness line, I don't know, to 2/3. So here we are, back to random again now. And I'm going to make it go. And now you have to have 2/3 of the people near you being the same colour as you to be happy. That's a lot. Let's see what happens. You can see the ticks, 1, 2, quite fast. And now you can see something really surprising happening. Which is that very, very quickly, I slowed it down by the way, very quickly you find red neighbourhoods and green neighbourhoods, and very, very unusual for any colour to be in the middle of the other colour. I showed this once to a group of social scientists last year, and before I started my talk, now this was in England, where we had huge numbers of different communities trying to all get on as well as they can with each other, and on the whole, getting on fine. But this is a social problem in a country like England. And I said before I started, I said, I hope nobody here is going to think that I believe that this kind of problem of, what is essentially, racist green and red blobs, I hope nobody's going to believe that I think this is a mathematical problem which can be solved by computer programming. They all said, no, we understand, this is just an example. And as soon as I showed the example, every single person put their hand up and said, how can you pretend that this is a problem that can be solved by computer programming? So I don't want this mistake to be made now. So, why am I showing you this example? Not because I think that this particular example is particularly important, but it is an example of how you used to be able to think about a problem like this in only one way, and that was by using differential equations. And I don't know what the Hong Kong maths syllabus is exactly, but you didn't really meet differential equations until you were about 17 or 18 years old. And in my country you can give up education completely by 16 years old. And you certainly, even if you stay in education, you give up mathematics and science if you want to at 16 years old, which in my view is a disgrace, but it's true. Is it true in Hong Kong? It is.
Yes, more.
Yeah. I think it's terrible. I think it's terrible that you can be a arts student who knows nothing about maths and science, and it's even worse that you can be a mathematician or a scientist and know nothing about arts and social.
Yeah,
but that's my prejudice. Yes, so once upon a time, I don't think people realized that phenomena could be modeled in this way. And then mathematicians said, no, we can model this kind of situation using differential equations, which means 90-something% of the world had no access to a problem like this. And now, almost anybody could look at this model, even if they don't see the program, just play with it and see what happens. And that's really important, I think. I think it points to ways in which the curriculum could change, but I don't know who's going to change it. And I don't know if the situation is different in Hong Kong. There is no pressure to make this kind of radical change. I would like to see social science being taught with digital technologies using this kind of idea, and I would like to see people learning about maths and science by taking real complex, this is a very complex question, this example, this model. And we have to hide I had a heading called complexity. We have to hide complexity, because if you have complexity, you don't have access to ideas that would help you deal with complexity. So we say to kids, well, here's a really simple idea. And the kids are bored by it. And you say, I'm sorry, I can't give you a real complex thing to think about because it's just too complicated. You need to know a lot of maths, you need to know a lot of science and so on. I think the digital IT has a solution for us, but I don't know who's going to implement that solution, because certainly in the textbook writers, there's nothing in it for the textbook writers. Do you have in Hong Kong, whose responsibility is it in Hong Kong to look at the curriculum and say, is this really the curriculum we need for the 21st century? Is it a government responsibility? So it's the Ministry of Education. Is it the person I'm going to meet this afternoon? Would anybody like to comment?